Okay, Algebra 2. We're ready to start our new unit. We had our Unit 1 test. You guys did really well on Unit 1. And we're moving into Unit 2, which is all about linear functions. Okay, we just studied functions and what makes it a function, what makes it not a function. We added, subtracted, multiplied, and divided them, did composition of them, chose the inverse of them. And now we're going to look at a special function called linear function. Linear function is a function whose graph just ends up being a straight line. Okay, if you would graph the function, it would just be a line. Okay, so every line has something called a slope, which helps when we know the slope of the line, we right away know how steep it is. Okay, you just take any points on the line. For example, this would be the point, 2, 1, 2, 3, 4. And let's go with this point, which is 1, 2, negative 3, 0. If you have 2 points on the line, you take the y coordinates and subtract them. And in the same order, you subtract the x coordinates and divide, and that's the rate of change or the slope of the line. It's sometimes called rise over run. Okay, it's how much is the line changing vertically compared to how much is changing horizontally. When we say y2 minus y1, don't get so hung up with the 2 and the 1. We just mean, here's an xy and here's an xy. If I'm going to start with this point for the y coordinate is 4, and I'm going to subtract this point's y coordinate, then I'm going to start with this point for the x's as well and subtract this. Okay, so this would be 4/5. Somebody else might have started with this as the y they wanted to start with. So they would go 0 minus 4, and then they just have to start with this point again for the x's and say negative 3 minus 2. So they would get negative 4 over negative 5, and a negative divided by a negative is a positive. So either way, we get 4/5. That means this line's slope, this line's steepness, is 4 vertical units for every 5 horizontal units. The reason it's called rise over run is from point to point, we go up 4 and to the right 5. How much do I rise compared to how much I run? Another way to think of it is I go down 4 and to the left 5. That'll get me to a point, okay? If I have a positive 4/5 slope, I can either go up and to the right or down and to the left, because a negative over a negative is positive. Okay? Another way we think of slope, if I have the equation of a line, which we studied in Algebra 1, y equals mx plus b, then the slope of the line can be found right in front as the coefficient of x. Okay, but that's only if the line is y equals, the y has to be by itself, mx plus b. All right, so we're going to use the slope to describe different kinds of lines. Okay, how's the line rising? All right, if it rises from left to right, in other words, like the line we saw on the other page, it rises from left to right, then the slope is positive, like we saw the 4/5. If, in contrast, the line falls from left to right, okay, a line like this that falls from left to right, that's a negative slope. Okay, if I want to get from this point to this point, I would go down 1, 2, 3, 4, 5. And okay, that's negative 5. When you go down or to the left, that's a negative move. That's negative 5 over positive, because I'm going to the right. 1, 2, 3, 4, 5, 6, 7, 8. So that's a negative 5/8 slope if I talk rise over run. If I wanted to go up first from this, I would go up 1, 2, 3, 4, 5, but then I'd have to, and that's a positive move, but then I'd have to go to the left 8. 1, 2, 3, 4, 5, 6, 7, 8, and left is a negative move. Either way, negative 5 over 8, 5 over negative 8, we just call that negative 5/8. Either way, okay? A line that's horizontal, okay, it's, that has a slope of 0, okay? It's not falling, it's not rising. If I wanted to see how many I go up and over, I'd go up 0 and over 1, or up 0 and over 5, whatever. It's a 0 slope. A line that's vertical, which we know, of course, isn't even a function, that slope is undefined. Okay, because I would go up, to get from this point to this point, I go up 2 and over 0. Well, I can't divide by 0. That's undefined. Okay, so a vertical line's undefined, a horizontal line, the slope is 0. All right, so let's look at some in your notes here. We have 2 points. If I want to find the slope, I take one of the y coordinates and subtract the other y coordinate. Then I start with the same x coordinate that I used for my first y. So I'll take 3 minus 1, negative 6 over 2. This is a negative slope, so this is going to fall from left to right. And you can just say falls from now on. Okay, we can just use these words. If I graph it, just if I'm not sure, 1, 1, and 3, negative 5. Oh yeah, if I would connect that line, that's a negative slope? Okay. For this one, I'm going to start with this y. 4 minus 9 over 2 minus 2. Oh, doesn't matter what it is. This is a vertical line, right? 2, 4, 2, 9. That's a vertical line. That has an undefined slope, so the line is vertical. Undefined slope. Here, if I take negative 5 minus 5 over 2, I'm sorry, geez, let's, I'm standing on my head or something. We're going to subtract the y's first. 2 minus 2 over negative 5 minus 5, or 2 minus 2 over 5 over minus negative 5. Either way, I either get 0 over 10 or 0 over negative 10. 0 over anything is 0. This is a horizontal line. Now these lines, oh, I don't have points this time. Okay. I just have an equation. I would like to make that look like y equals mx plus b. So I need to get this y by itself. I'm going to have to do some manipulation. I'm going to distribute the 2 through. I'm going to subtract 6 from the 4. And I'm going to divide by negative 2. Okay, divide this by negative 2, divide negative 2 by negative 2, divide negative 12 by negative 2. So I have y equals 6x plus 1. I made it look like this. So now I know the slope is 6, which is positive. So because it's positive, it rises from left to right. I can't tell what's going on here, and it has to say y equals, okay? So I'm going to have to subtract that 2x to the other side. All right, I'm subtracting 2x over with the negative 15, and then divide everything by negative 3. Negative 2 divided by negative 3 is 2/3. Negative 15 divided by negative 3 is 5. This is a positive slope. My slope is 2/3, so it rises as well. Here we need to get the y's together. So I think I'm just going to add 3y to the other side to keep everything positive. 5 equals 5y minus 15. Guess I'll add 15 to the other side. I have 20 equals 5y. Divide by 5, I just have y equals 4. Well, y equals 4 means the y coordinate is always 4. If I would graph that, it would just be a horizontal line up here at 4. Okay? Y equals 4 is a horizontal line with a slope of 0. Okay? So that's just an idea of how, whether you're given 2 points or whether you're giving an equation of a line, you can find the slope and you can describe it. Okay? You should be able to describe what the line looks like just from the slope. Does it rise from left to right? Does it fall from left to right? Is it horizontal or is it vertical? Okay, so let's look at comparing the steepness of the line. If we take the absolute value, okay, so in other words, we're going to make the slope positive and then compare them. The bigger the absolute value is, the steeper the line. Okay, so let's take these lines 1 and 2. Let's find the slope of this one. I'll take -12 minus 8 and 1 minus -4. Maybe you did 8 minus -12 and -4 minus 1. Either way, we're going to get the same answer. I get -20 over +5, which is -4. Line 2's slope, let's see what that is. I'm going to take 5 minus -4, -1 minus 2. I get 9 over -3, which is -3. So I'm wondering which is steeper. So I look at the absolute value of each. I'm comparing 4 to 3. 4 is bigger, so line 1 is the steeper line. Okay, if I wouldn't have taken the absolute value, sometimes people say, oh, you just take the bigger number. Well, -3 is bigger than -4. So I might have thought that this was steeper. You have to take the absolute value and then compare them. Okay? If I would graph 1, -12, which I can't, -4, -8, okay, is way at the bottom. -1, -12 would be kind of tough to do. 8, 9, 10, 11, 12, it's about here. If I take that slope, and then I take this one that goes through -1, 5, oops, -1, 5, and 2, -4. Okay. Again, I don't think I graphed that quite right. But, oh, and I didn't even, I'm sorry. It was 1, -12, not -1, -12, right? I didn't graph these right at all. Okay, don't graph them. I'm going off the edge there. Okay. All right, let's try it again here. 1, -12, 8, 9, 10, 11, 12, and -4, 8. Gosh, I don't know what I was doing. That, wow, super, that's that steepness. And then -1, 5, and 2, -4. Okay, it's hard to tell the difference too much, but this line is a little bit steeper. All right, the next one we'll do in the next video.